My name is Dana DeFilippi, coming to you from BIMXT Network. Today we have a really wonderful topic on MEP and mostly on the analysis and some of the new preliminary tools surrounding the MEP field and discipline, if you will. Today we have three fantastic presenters. Without further ado, I'm going to move over to Jason, who's sharing our tip with us today. You can see Jason's information. Oh, it got moved by somebody there. But Jason is going to talk today about some of the MEP features. Do you want to talk a little bit about the group, yourself to the group? Tell everybody a little bit about you and your role.
Sure. My name is Jason Peckovitch. I'm currently the corporate BIM manager at Shive Hattery Inc. here in Cedar Rapids, Iowa. I've been in the AEC industry since 2007, where I was working in Denver, where I was a BIM manager for a couple firms out there before moving to Iowa. I also do photography, published in magazines for automotive. I've written articles for Augie, got a couple kids. I'm a gamer, like comics. We were talking about comics before everyone got let in, stuff like that. All around tech guy. Those intros are always fun.
Absolutely. Well, without further ado, if you'd like to jump into your presentation.
Yeah, I gotta. All right, so today I'm going to talk about Revit 2023, right? So I want to assume that all of you here today, you're here because you want to be on the forefront of technology. You probably geek out on this type of thing. I know I do. I know Dana does. I'm pretty sure Jason does, and a lot of other people here on our panel, as well as you attending, right? As MEP designers and engineers, or even you representing your firm, our technology uses is often dependent or held hostage by our clients, whether those are the owners or the architects that you're working with, right? I want to talk about some improvements with Revit 2023 that could help sway your team and your owners to possibly upgrade those projects from the older versions of Revit to take advantage of those new improvements. Those improvements go across all disciplines, architecture, structure, MEP. There's a lot of generalized improvements, but I'm just going to talk about today is several of the MEP improvements that could help you, with your progression to upgrading. Okay. Make sure I got that right. All right, so the first thing I want to talk about is new categories, right? So in 2023, we finally have a plumbing equipment category. For the last 15 plus years of Revit MEP, we've had to use the mechanical equipment category for plumbing. So now there's a new plumbing equipment category. There's also a new mechanical control device category for your thermostats, your humidistats, or temperature control devices, for things like that may have been on like I've used communication devices in the past, or electrical fixtures, or whatever. You may have to do some random workarounds to get that stuff to show up correctly. Now there's new categories. The out-of-the-box families have been switched to these categories, but if you have families built and you want to switch them, you'll have to do that manually. There's also a couple new buttons on the systems tab for those. Coincidentally, in 2022, about a dozen new categories were added to Revit, but none of them have a button. How do you get those added to your project? Hopefully we can get that sorted out with Autodesk. I know I did reach out to them about that. Next, I want to talk about the MEP connectors, right? The connectors are really the heart and soul of your families, aside from the rest of the data that you schedule, right? So you transfer information from these connectors into your electrical systems, your duct systems, right? In the past, when you deleted the element that was hosted to, then your connector got deleted and you lost all that information. right? Then you had to re-add it back and then remap everything back to those connectors. It was very cumbersome. We have a workflow at Shive Hattery where we have placeholder families that just have a box and a connector on them. And the premise is that the user downloads a manufacturer content, they embed or nest that family into the placeholder, and then they add the additional mechanical connectors. But the electrical connector is there. And a lot of times they would delete that box and then the electrical connector would disappear. And as a mechanical, they don't know what those parameters are for electrical. So then they can't circuit to that piece of equipment. Now they can embed their families, move that connector, and then delete that box. My big yes moment for 2023 was the release of the maintaining of systems when demolished. In previous versions, when you demolished any of your systems, your content, it all became not orphaned, it was undefined, and you couldn't do anything with it. It lost all of its information. It lost connection to the next piece of equipment that was next to it. The fittings, everything was disconnected and essentially broken. Now, everything is maintained, the system name, the abbreviation, your classification parameters. Everything's connected. When you move it, everything moves together, right? Where everything was independent previously. To me, that's a huge improvement for MEP and probably my sole reason to upgrade and start using 2023. Now, I have a couple electrical specific ones that I want to talk about. This one here is about circuit number, right? So circuit number wasn't available for equipment, electrical equipment. So you couldn't see it in your panel schedule. You couldn't see it in the family. You couldn't, tag it. Now they've opened that up. So now you can tag it. You can include it in your panel schedule. And that information is also in the family information. Something that Mike is going to talk about later in the presentation, so I won't get too much into it, is electrical preliminary load analysis, right? So you can perform electrical loads right in Revit just by defining some areas, giving it some information, and have it do that work for you before you even place any of your families. So Mike's going to get into that in more detail at the end of our last presenter today. Another big electrical one, electrical families are mostly symbolic based, right? If something was on a ceiling and you showed it on a floor plan, it looked differently. The symbol was flipped or reversed, or text within the symbol looked funky when it was on a different orientation on the wall. So now they've improved that in 2023, where that annotation actually flips with the family as it flips over a wall or is visible in the ceiling or the floor plan. So everything looks the same. Now you're probably going to have to go back through all your families and flip them to be the correct way if they're ceiling based. But now they'll look correctly in floor plan and ceiling plan. And then lastly, with the 2023.1 release that was released on November 15th, they've added the ability to have the split with gap function in Revit work with many of the system families for MEP, duct, pipe, conduit, cable tray, even some of the fabrication stuff. You can now use that split for gap, put a gap in your automatic, you can set the spacing, put that gap in that duct. You can drop that duct and connect it up, and as opposed to, split, click on one space, click on another space, and then delete that middle piece. So now it's just split with gap and then move it to where you need it and reconnect it. There's also some fabrication improvements with this release, but I don't use fabrication personally, and I don't know anybody with that uses fabrication. So I didn't include any of that stuff, but there is a link next to my name on the mural for the what's new. If you click on that link, that'll take you to all the what's new information for 23 and 23.1 that you can peruse for yourself. There's a lot of great generalized, sheet layout stuff and whatnot that you can check out. And be sure to use that information to help navigate your teams to a newer version of Revit, as opposed to being stuck in the past. That's all I got.
Thank you so much, Jason. Seems like that's calling a lot and some big things, right? I mean,
Yeah.
It seems like those are some real big game changers that we've been asking for a while.
Yes. I
It
know.
seems like it's kind of like the trend. This latest release, right? They really wanted to publicize how many ideas they made happen with this release, right?
Yep. I saw a LinkedIn post today that Kimberly commented on, that they outlined how many things were done in each of the releases since 2019. And it's just, sometimes it feels like there's not a lot, but if you look over the years, there's a ton of stuff that they've done.
Yeah. This is
a lot of
I know the hosting things from working with Smith Group, with multidisciplinary, that hosting has been such a nightmare. And so hopefully they continue to work on that. But with the connectors, and the holding of content with the demolished, I mean, that's just so much time saved in the overall process when you're going through those things and you're like, why am I even having to do it? And it's taking me hours, right? So definitely know the struggle. Well, thank you so much. I hope everything at home calms down and gets back to regular soon.
Yeah, hopefully. Thank you.
No, absolutely. I'm going to go ahead and share my screen once again. Seems like you guys are off and away with Mural, which is fantastic. For those of you guys who just joined us or joined us recently, I did throw it in the chat again so that you can join us in the Mural. Once again, the Mural has these notes over here that you can essentially move and converse with us, whether that's sharing your location, asking a question, or just information to share about MEP and some new features that you've really enjoyed, or a tool that you've found a special way of using that's awesome. That'd be cool. You can see last time we selected a winner, as we do every time. For Julia, doesn't look like she's on this meeting, but please feel free to share with us. We do choose a winner. Julia is going to win a $25 gift card. Sometimes the prizes are much more significant. Sometimes $25 gift card is exactly what you need, right? Now I got something in my cart that $25 would help me with. Now, over on the very far right, you can see we actually have links to all of our previous meetings. We actually record all of these meetings, as you probably saw, and post them up to our YouTube channel. So you can, once again, double click on any of the links down here in the very far right where it says open link, and that will open up the video from our YouTube channel on any of those previous meetings. So please feel free to bookmark any of those so that you can watch them in the future. Our next presentation is by Zach. Hey, Zach, how are you doing today?
Doing all right. How about you?
Doing well. Thanks so much. You want to tell everybody a little bit about yourself? Zach's a board member in addition to whatever he's going to say. Let him give the introduction.
I'm Zach Emerson. I'm a virtual design and construction coordinator with Clancy and Taggy Construction. I have been in the construction industry going on about 15 years now, and I've been with Clancy and Taggy about 8 years. And Dana, there we go.
I was just showing everybody, you can get to all of Zach's information right there. Zach is an awesome individual that, once again, as a board member, contributes to these meetings. So make sure you connect with him.
All right. Are you able to see my screen?
I am.
Okay, great. So today I'm going to be talking about our kind of internal BIM coordination process, and more specifically, digital field layout. So using a robotic total station and the Autodesk point layout add-in for Revit to perform digital layout in the field, as opposed to the more traditional kind of old-fashioned way. And I thought a great place to start would be with some background on kind of that traditional approach that we've previously taken, especially for those who may not be as familiar with the construction side of things. So this is an example of a plumbing dimension plan for laying out MEP sleeves in the field. We were using this approach in our office up until fall of 2020 or so. That's when we really started reaching toward using a more technologically advanced approach. So taking a closer look here, you can see on the left here, we typically would establish control lines that are dimensionally tied back to column grid or some other known building coordinates. And then from that, the trades would come use this dimension plan to locate each sleeve individually. And that would basically mean, intersecting these two dimensions to place each sleeve. Very manual process, obviously a lot of room for error there, but also just a very time-consuming process. So
yeah, very tedious. You get to work and you're like, God, I'm gonna have to do that task today.
exactly, and also just the sheer number of sleeves on any for this is a residential project, so it is very easy to potentially overlook a sleeve or pull the wrong dimension for the wrong sleeve. But the main driver really was the time factor. In order for this process to start, you have to get your concrete form deck up, and almost as soon as that happens, you typically have rebar installation starting as well. The preferred approach is to get all of your sleeves in first, just because rebar can really, take up a lot of space. And if you don't have your sleeves in the right location early on enough, you've got to work around rebar that's already in place. It can just really get away from you. And that time factor is really what drove us to advance into the start using some of the digital layout tools. So a few months later, summer 2021, we had our next major podium project, and our concrete contractor actually approached us and recommended that we try using some of the point layout tools. They used a robotic total station for all their formwork layout and really recommended using it for sleeves and embeds and other concrete related or adjacent components. Between just the speed that concrete contractor works at, and also the fact that this was a post-tension podium project, so lots of very critical structural components embedded in the slab beyond just your standard steel reinforcement, really required that we were able to lay out sleeves accurately and quickly enough as to not slow them down. So we partnered with them and started working on really adding this layout process to our coordination efforts. Typically for coordination, we work closely with our mechanical, electrical, plumbing contractors to get their sleeve locations identified, whether it's just a kind of typical unit plan for repeated unit layouts or more specific needs for risers up through the building, things like that. It's a very involved process. We usually would sit down with them and kind of go through one by one and designate dimensions for each fixture type or each unit type to really get those sleeves located as accurately as possible. From there, we would generate a point file. As you can see, some of these points centered on sleeves and embeds. And then we sent that to our concrete contractor, who actually handled the layout process for us as part of their formwork layout. It was a pretty effective process. There were a few lessons learned along the way, And I'll get more into detail on the actual workflow of doing that point layout later on in the presentation. But one of the main comments that we got, not only from the concrete trade, who greatly appreciated being able to maintain their schedule, we also got comments from our MEP trades that they never wanted to do it the old way again, just because it was so manual and took so much time. Plus, the constant feeling of rebar, right on your back. So, but another, aspect that we identified really in this first project was the cost of subcontracting this layout, just the, actual robotic total station layout portion to our concrete trade was roughly the same cost as an entry-level robotic total station. So we kind of started considering bringing some of those capabilities in-house. Around the same time, and this is a reused picture, but you get the idea. We also started using the same point layout process, again, integrated into our MEP coordination process. And then rather than working with the concrete trade, we actually sent the final point file layout to a third-party surveyor who performed all the layout for us. Again, similar costs to investing in a robotic total station. So on our next major project at the end of 2021, we finally bit the bullet, so to speak, and bought our own robotic total station, Hilti PLT 300. One of the main reasons we selected it was actually recommended by a few of our trade partners for its user friendliness and just ease of layout. And just kind of an overview, here's a time lapse of one of our superintendents performing layout, but you essentially set up your robotic total station, site it into known control points on site, and then the total station will follow around the prism on the top of this rod, and it essentially guides you from point to point. And each time you lay out a point, it directs you to the next closest one, which really ensures that you never miss a sleeve, and obviously really speeds up that process and allows you to get all this layout completed well ahead of any mild steel reinforcement, or especially any post-tension tendons or other structural elements going in. Another
While you're
advantage.
at it, it seems like somebody, Brian, thank you so much for your question. What software are you using for your point creation?
So I'll go over that in a little bit, but
Perfect.
we've primarily been using the Autodesk point layout add-in for Revit, and we've had a lot of success with that.
Awesome. Thank you so much. Sorry, I didn't mean to interrupt.
No problem. One other thing I wanted to add, one of the advantages to this Hilti system that we have used some, you can actually load a CAD file directly into it, completely independent of that point layout add-in for Revit, and work straight from the CAD file to generate layout points. And, it's more or less all self-contained right there on site. So on this same project, we not only, made some improvements and got a little more sophisticated in our workflows, but we also started seeing some of our subcontractors get a little more sophisticated as well, working from marked up PDFs rather than the, hands-on sitting down with them that we were doing, just a year before. In addition to that, we've also kind of started receiving CAD files and some other just easier to use processes. So you can see here, we got a marked up PDF locating just a handful of common area sleeves. And then we worked to get those placed within the Revit model and then work through our coordination process, weekly meetings with the trades, just to review and confirm those locations. And here's an example of just a typical unit plan that we received that allowed us to actually create model groups for repeating units. There's occasionally you might need to, create a one-off for different unit layout. And here are just some more examples of the actual equipment involved. So this is the total station set up on a, kind of remote location where you're able to sight into your known points. And then here's your prism and rod used to locate and then mark and lay out your sleeve locations. Another example of just how important it is to get these sleeves in there and located correctly, and just the amount of, other elements in that slab that, once it's all placed, you don't really see. Here's just an overview of our workflow. Quite a few steps involved, but the highlights are, we work from information provided by our trades. We work through our coordination process with them to, finalize those locations. We send the finalized layout to those trades for final review, as well as to the design team for any comments. Any final comments we get are then corrected. From there, we generate the point layout and either send it to the responsible party or our field team for internal layout. And then those trades follow almost immediately behind, setting those sleeves as soon as possible. And then we also will, I'll touch on this in a minute, but we follow up with a drone photo, just straight down view of the slab that we then overlay with our layout to make sure that everything lines up as best as possible. From here, I'm gonna switch over to Revit just briefly. So this is an example of just one of our concrete pour areas. We've done most of our coordination already. As far as let me see if I can. Okay, so this is the Autodesk point layout add-in. Kind of the easiest process here is you can do an instance and choose a sleeve point. It actually automatically picks the next sequential number for you. And then you can select the type so that it puts the description of exactly what that sleeve is automatically. Select all your different sleeve types, or you can select them individually just depending on how you want to number them. And then it generates a series of points. You can create a schedule from it. This is one I had set up in advance. And I will jump back over to my presentation. So this is just a couple examples of that drone overlay that we do to really do some quality control, confirm our sleeve locations after the fact,
so cool.
Prior to the pour. This is a great example that one of my coworkers in the Raleigh office put together that really shows, how much information you can build into this review process. All of this is in a self-contained PDF that can be sent around for review. But it between the point layout and then being able to follow up and do some quality control with this really makes the process easy. Just a couple of additional examples of that.
Are
as well as
are those a compilation of photos that are put together from the drone, or is it like one giant photo? Do you know?
So we kind of have taken both approaches. Some are an ortho mosaic where it's a composite of multiple images, but sometimes you'll get a little bit of skew with that. So it's better if you can do just one complete overall image.
Interesting. Okay, awesome.
Here's just a quick shot of what those sleeves look like once the form deck has been stripped and once install is started. And then just another example of, these are in kind of reverse order, but where we had some sleeves missing that were identified by the overlay and then able to be placed prior to concrete pours. There are a couple other additional layout uses that I was going to go over, but looks like I'm a little short on time.
Let's see here. No, I think you have a few more minutes there.
Okay. One other use case for this that we're not using in my office, but again, wanted to highlight our main office in Raleigh actually has a full-time surveyor in-house who I'm not sure that they're doing much advanced layout for the sleeve layouts. I think most of their trades handle it themselves. So he will actually come around with more or less the same process and back check any, structural embed locations, sleeve locations. And then from that, he's able to generate a deviation report, show where we have certain embeds or sleeves in or out of tolerance. And overall, I mean, we've really just had great success with this whole process. And I would say it's well worth the investment, at least for us.
Well, it seems like many people agree. It seems like we're getting quite a few comments in terms of people having used this software and never going back, as you're mentioning. And so for those of you who are on the fence, I would say that this is definitely the way to go, right? Make no hesitation. Everybody who is using it is absolutely loving it and wouldn't have it any other way, right? It seems like
Absolutely.
the way to go. Awesome. Well, thank you so much, Zach. That was a fantastic presentation. Please keep the questions coming for Zach or any other presenters as you come up with them. Please join us on the mural if you have not already. I will copy that into our chat here so that you can join that for those of you guys who just joined us. Looks like Gary is saying that, with all due respect, drone imagery is not capable of depicting improvements to a 16th inch accuracy. He also says, while using the total station and the CAD add-in is undeniably the most efficient method for such layout, it is critically important to manage plan integration before visiting the field. Any comments to those, Zach or Jason even?
I would say the drone overlay is more intended to show sleeves that are out by, as you mentioned, well above a 16th of an inch. We typically work to a 1/4 inch to a 1/2 inch tolerance where possible, just to make sure that the sleeve is at least located in the intended wall, if not, dead on where it needs to be.
Right, so more of a representation of is overall accurate and we can find the glaring problems and go back and refine.
Right.
Awesome. Thank you, Gary, for your input. I very much appreciate this. And this is very much a conversation. So as I mentioned, the mural is a wonderful way for you guys to communicate with us. If you do communicate with us in the chat, as Gary is doing, we will see it. So in any way that you can, please communicate with us. Last but not least, we have Mike. Hey, Mike, how are you doing today?
I am doing well. How are you doing?
I'm doing very well, thank you. We must thank Mike. Mike is a last-minute presenter. So for those of you guys who joined or registered the group a long time ago, you may have not seen his name on the ballot as a presenter. However, he is going to present a condensed version, obviously, of his AU presentation. We're very grateful to have you today, Mike.
Well, thank you. Yeah, I'm excited. I'm a newbie here, so this is my first time to be part of MXT. So I'm excited.
Happy to have you. Happy to have you. You want to tell everybody a little bit about yourself?
Sure. Let me go ahead and tell you what. Let me go ahead and share my screen. I've got a. Okay.
We got it over here.
Perfect.
Sure do.
Yeah. My name is Mike Massey, and I am a senior practice manager at CADD Microsystems. I've got about 30 plus years. I'm kind of aging myself by saying that, but I got 30 years experience in the AEC industry. I actually started as an architect, got a degree in architecture from Texas A&M University. From there, I went on to work with several resellers and became an expert at MEP. When I did that, I was asked to learn the MEP products, and for about 15 years straight, I did pretty much nothing but MEP as far as implementing MEP for both designers and contractors. Went on to work for a company that we did BIM services for, where I not only managed, but I managed projects for contractors using electrical primarily. So electrical is my love. I love electrical projects. I love Revit Electrical, and I'm excited that Autodesk is finally giving us some new tools. Something like Jason said in his presentation, it seems like sometimes it's kind of skimpy on MEP new tools that are there, but this release, there are some new tools, and I'm excited to showcase one of them today. Like Dana said, this is a presentation that I did at Autodesk University. I'm going to condense it down a little bit for you so we can fit it in today, but I think you'll be able to understand. So what I'm focusing on today are the new tools for electrical analysis. These are preliminary tools that are in Revit 2023. And I've divided this up into four different sections to kind of break it down, but I think it will show you a typical workflow that you can use to begin using these tools. The first section that I'll talk about is define, where you can go in and start defining the electrical analytical load type settings. And so there's some new settings in Revit that I'll show you that we can set up to get our projects ready for this analysis. And this is the first step in there, is to set up these electrical load type settings. Once we have those settings defined in there, then we can get into the create section where we can actually start creating electrical analytical loads. And we can either do this one of two ways. We can either use what's called an area-based load. An area-based load will allow us to define an area in our plans, and it will multiply the square footage of that area by a power density that we set up in our load type settings, and it will give us a load for that area. Another type of load that we can create in Revit 2023 is an equipment load. And this would be for something that's outside of the area-based load, something like maybe for elevators or for major equipment that's in the building, that we can go ahead and just assign loads for that major equipment that's not based on a square footage in there. So I'll show you how we can create both the area-based loads and the equipment loads in there. Once we have those created, the next part is to apply, where we can come in and apply these loads to a conceptual distribution system. And this is another new feature inside of Revit 2023, being able to create a conceptual distribution system. This is going to be using the system browser that's built into Revit, but they've got some new tools in there that we can start defining our electrical loads prior to placing any families in our project. We could do this in previous releases, but we would have to have families in our projects first. But now we can do it preliminary before we start putting families into our project, so we can get some estimates in there at an early stage of the game. And finally, the last step would be to document. Once we have all this created, we can document this information either with tags and or schedules. And I'll show you how we can use that to document the process. So if we jump into the first section, define, again, this is where we're going to define some settings, and these are going to be the electrical analytical load type settings. And so these are going to be used with those area-based settings. And so when area-based loads. So when we start creating those area-based loads, it's going to use these settings to figure out the loads for it. But first of all, let me just kind of talk about what's new. So we got these new tools in Revit, which is great. We can do this now before placing any families inside of Revit. But let me just say this: electrical designers are probably going through this process today, but they're just doing it outside of Revit. They're using Excel or other programs that are outside of Revit. But it's great now that we can now bring it back into Revit and use the Revit model as the basis for these preliminary analysis loads. And so that's what's new. And again, we can create either an area-based load or equipment load, and we're also able now to create the distribution system. I will mention these new tools, they work with a Revit model. You can also use a Revit linked-in architectural model to help you define the areas in there. So that's what I'll be doing, is using a linked-in architectural model. But it can also be done with a DWG or a PDF format. The workflow would be exactly the same. So if you do just have a PDF or a DWG, we can bring that into Revit and use that as our background and go through the same process. And currently, this is the first release of these tools. So hopefully that means that there will be improvements in future releases, but currently it only supports 3-phase systems in there. So that is a limitation to these tools. But as far as defining those electrical load type settings, there's a new set of settings under the Manage tab. If you go up to the Manage tab and use the MEP settings dropdown, you'll see a new set of settings called Electrical Analytical Load Type Settings. And if you go into here, there'll be a couple of load type settings there by default, and you're free to use those if you want to, but we also have the ability to create new ones, duplicate them, rename them, delete them, whatever we want to do as far as creating other load type settings. And I would recommend creating a load type setting for each type of space that you have. So depending on your project, depending on what type of building it is, you may have common areas, or you may have resident areas, or you may have office areas, or you may have different types of areas in your building that will require different electrical loads. And for each one of these, we can create and assign the power density for that type of space. We can assign the load classification, the power factor, and the parent power density for each one of those. And so we can set this up. And once we have all these set up and created, we'll then start assigning these to those area-based loads that we're going to be creating in there. So that's the first step, is to define those electrical load type settings. The next step is to go ahead and create your analytical loads. And again, there's 2 ways we can do this. We can either use an area-based load or the equipment loads. For the area-based loads, we'll be using the plan as the guts of defining those areas. And once we have those areas defined, we'll create the area-based loads from that. And then the last step is to, once we have the area-based loads created and the equipment loads, we'll go back and we'll assign those loads to a power source, either to a panel or to something as far as where that load's coming from. But before we can do that, we'll first have to create that distribution system, so we have some panels to connect these loads to. But we'll go back and do that after we have that distribution system created. So as far as creating an area-based load, in there is really 3 steps to create an area-based load. We first have to create a boundary, a load boundary, and we'll use a new tool inside of Revit called Load Boundary to create that. Essentially, it's just a closed-in area, a closed-in line that defines the boundary. Once we have that closed-in boundary created, then we'll come back and actually create the load from that boundary. And then once we have the load created, we're free to come back in and subdivide that load if we need to. So we could create one overall load for the entire building and then start subdividing that into separate loads inside that overall load. So to create the area boundary, like I said, there is a new tool called Area Boundary, area-based load boundary. I'm getting my words mixed up there. There's too many B's in that tool. But essentially, once we start that, it does go into what's called a sketch mode. And we can use our typical Revit sketching tools to trace out or define the boundary. The boundary does need to be a completely closed-in loop with no bad corners or anything like that. But we can use our modifying commands as far as align and trim and things like that to trim it out to create our boundary. My wish is that hopefully one day in the future, they'll be able to use maybe spaces to help us define these boundaries. But right now, it does not do that. We have to completely draw the boundary every time. It's kind of like you know, in AutoCAD, we can use the hatch command and it finds the boundary for you. But in Revit, when we use the field region command, we have to define the boundary. Same thing here. We have to define that boundary as far as what it is. We do have a couple tools in here to help us to make sure that we don't have closed open ends or bad intersections or anything like that. We can show open ends to help us find, you know, where we have open ends to clean that up. And we can also define, there's a specific new line style inside of Revit that we can assign these boundary lines to be on. So if we want to change the graphics of the lines, we can do that as well. Once we have that boundary created, then we'll move on to the area-based load command, where we actually will create the area load. And we simply do that by starting the command, and we'll get a contextual menu that pops up that allows us to either add a load area or remove a load area. So we can add and remove to this, but we just simply add pick the boundary that we want to add to the load, and it creates the load for us based off the square footage. Once we have the area created, then in the properties, we can go in and start assigning the load type to it. So that going back to those settings that we set up on the first step, we'll assign one of those load types to this area, so it knows what power density it's going to use to multiply and get the load. So we'll assign that. We can also give this area a name. So maybe it's a location like first floor, northwest resident area, whatever it is. We can assign a name to it. And if we already have a panel in our distribution system, we can go ahead and assign that supply from parameter as well. But if we don't, we'll come back and do that once we get that done. Once we create the load, we can also divide the load, like I said. So if we create one general area load for the entire floor, we can come back in and pick on that load and use some divide tools to divide that out and create sub areas inside of that. So maybe we have an area of that floor that's a mechanical room that has a different power density. We can simply just divide that out and create that mechanical room and assign that to be a different, use a different load type setting. I do recommend the use of filters when you do this, because without filters, all these areas will look exactly the same. And so filters will allow us to create color codes, so we can kind of visually tell, you know, which area is where in our plans. So I recommend creating a filter for each type of load that you have in there. So if you have, you know, a common area load and equipment area load, you know, create a filter for each one of those. And then we can apply those filters to our, our view templates or our views, and assign colors to those so that we can graphically tell in our plans, you know, which areas are where in there. Otherwise, they're all going to look the same. And then the last step is the next step is to apply. And this is where we'll create that conceptual distribution system. And again, like I said, this is going to use the system browser. So if you're not familiar with the system browser in itself is not a new tool. It's been around for many years, but they've added a new part to the system browser. So at the top of the system browser, there's going to be a drop down that you can change and tell it that we want to view the analytical power distribution. And when we do, we'll start seeing the new tools in there that we can use to create this distribution system. And to create it, what we have are essentially 5 new buttons at the top of the system browser that we can use to create either a power source, which would be like a utility source or a generator. We have a tool to create an analytical bus that would represent a panel or a switchboard or a busway, etc. And we have a tool to create a transformer, a tool to create a transfer switch. And the transfer switch is unique because it actually has 2 power sources. And then we also have the electrical equipment load that we can use to create the electrical equipment load for things like elevators and major equipment that we have in our building. So we essentially just build this out. We start picking on these buttons, and it's almost like building an Excel spreadsheet where we can pick on the button and it will create the load for us, and we can adjust them and tell it what it's connected to. And then once we kind of have it built out, then we can go back and start assigning those area-based loads to the equipment, to the power source. So initially, when you first create all the area-based loads, they're not going to be connected to anything. So they're all going to be grouped under the unconnected folder at the top of the system browser. But as we start connecting those and assigning the power source, they will move underneath that power source. And when we do, you can see that the loads add up. And so if we have a panel that has 3 different areas inside that panel, it's going to add those loads up for the panel and give us a total estimated panel load in there as well for that. As far as the equipment load, if we do have equipment in there, we can just add the equipment, and on the equipment, once we add it, we'll switch back over to the properties. And on the properties, it's not using a square footage or anything to calculate the load on that. We just simply assign the load to it. So we can assign, the load classifications, the voltage, the power factor, the parent load. We can also tell it, which panel it's coming from as well in there. But, that's just kind of like a standalone piece of equipment that we've come in and assign the load for that separately from everything else. So I do want to switch over. I do have Revit open and a sample project open that we can jump into. This one is completed, but I did want to show you that system browser. So if I open up my system browser in here, this is already all hooked up in here. But if I start expanding this out, what I've got in here is a generator for this project, but I've got, as far as my service coming from my utility, I've got a main switchboard for the campus, and then I've got a transfer switch, and then a main switchboard, and then I got all my panels in there. And each one of these panels, I've assigned those area-based loads to it. So I've come in and I created the area-based loads, and I told it which power source it's using, and it's doing the math for me as far as calculating the square footage of that area, multiplying it by the power density to give me an estimated load over here. And then, like I said, it's summing all this up and connecting it up to the panel, giving me a total panel load. And it's coming up, and we can get very quickly in here a load up here. If we go up to the utility, we can see all the loads added up for you together in there as far as that total building load. And so again, this is something that we could do in previous releases, but we would have to have all these panels in our project. I don't have a single panel in this project. This is all analysis, all analytical. And so this, another wish list item on my list is, now that we have this analytical distribution system created, can I now go back and just put in panels and it will read my distribution system and automatically map it out to my analytical distribution system? Can't do that yet, but maybe one day.
Almost like
future,
a placeholder.
It might be able to do that. Yeah. But for now, we would have to manually come in there and put our panels in there to match our distribution system. All right, let me jump back to my PowerPoint real quick. And then the last step I've got in here is just, I want to talk about how we can document these loads. So we can either use tagging to document them. So we can either tag, the area-based loads in our plan, something similar to what we have on the screen here. There is a new category inside of Revit for these tags. It is an area-based load tag. So if you do create a tag from scratch, that is the category that you're going to assign the tag to use in there. But there's, just like any tag, we can use different parameters or pick and choose which parameters we want to use for that tag. In this case, I've got the actual name of the area load in there. I've got the power density, I've got the square footage, I've got the total load, and also the panel source as far as which panel these loads are connected to. So again, a lot of information can be included in just tagging a floor plan. And then also we can create schedules. There's actually 5 different schedules that they've added to the Revit scheduling command. We can create a schedule for just the overall loads, and that's the main schedule that you see here on the screen, just calling out all of my spaces that I've got in there, and where it's being supplied from, the power density, the area, the parent load, and calculating and summing all that up for me for each level of the building. But you could also create just a analytical bus schedule, or a power source schedule, or a transfer schedule, or a transformer schedule. So those are the new types of schedules that they've added in there. But again, it's reading all this from that analytical distribution system and calculating that for you. So again, it's pretty exciting. I like it. It's new. It's going to require a change as far as the process that electrical designers are using today, moving them away from Excel back into Revit. But I think it's a step in the right direction to get them to do that. So again, wrapping it up, I'll just say that you can define, create, apply, and document would be the steps that I would follow if you want to start practicing this.
I actually grabbed a screenshot of this and threw it on the mural because it's such a great little overview of the process. So thank you so much, Mike. That was a wonderful presentation and overview. Seems like there's a common theme here that there's a bunch of new features. It's going to be different, but it's totally going to benefit you in so many ways. So don't be scared. Get over that hump. In addition to the page that you just saw with Mike's information, we of course have it on the mural. So thank you so much, Mike. Thank you so much to our presenters. It is the top of the hour. We went a minute or two over, but such great information from all of you guys. Fantastic presentation. Hopefully all of you enjoyed it as well. Make sure you join our LinkedIn group for more information on future presentations, and of course our YouTube channel for all of our videos. Thank you all so much for joining us today.